Hello, this is Mr. Huber. In this lesson, we're going to learn about compositions of transformations. Compositions of transformations are when we put two or more transformations together within the same problem. We're going to do two at a time here, but you could do more. And also remember that an isometry is when the original figure, the preimage, is congruent to the image. And even if we do two transformations, that isometry is going to stay through all of those. So if you have composed more isometries, you still have an isometry and it's still congruent at the end. And we're going to use prime and then double prime, and you can use triple prime. So when you note the different images that you get, each time you add another prime to that. So A would go to A prime to A double prime, as we'll see. So make sure we know that notation. And we're going to start by doing something called a glide reflection. So there's a term when you do a translation followed by a reflection. Okay? Not all other compositions have names for them, but here a glide, translation, when you glide, you slide something, and then the reflection. So we're going to do that here for CD. So we have a segment CD, and I'm going to draw that original figure, CD. C is at 1, 2, and D is at 5, 4. Okay, so we've got 1, 2, and then 5, 4, and I'll draw in the segment there. That's C and D. So we've got our 2 points now. We're going to first translate them. So first we're going to do the translation, and we're going to go to the left 4 and up 2. So these points are going to go to the left 4 and up 2. And we'll draw this one here in blue. So we'll do point C is going to go to the left 4 and then up 2. And we'll have a point right there. This would be C prime. And then D is going to go to the left 4 and up 2, and we'll have D prime. And we connect those, and you should see that it looks like the same segment, just slid over left 4 and up 2. Every point, left 4 and up 2. We have that same figure, congruent to what we started with. C prime, D prime. And now we're going to do a reflection. The reflection is from C prime and D prime. We don't go back to the original. We take this image now, and we're going to reflect that. So we do the translation, and then whatever figure we end up with, we do the reflection to that image. So now we're going to reflect in the x-axis. So reflecting across the x-axis means these points are all going to flip down below the x-axis. And what that would look like here, C prime is going to go now 4 units below the x-axis. All right, it was 4 units above, now it's 4 units below, and that's C double prime. Okay, note 2 primes. C prime then goes to C double prime when we reflect it. And then D prime is going to go 1, 2, 3, 4, 5, 6 units above. Now it's going to go 1, 2, 3, 4, 5, 6 units below. So we're going to have double prime, D double prime, okay, right there. D double prime, and we connect those. Again, double prime notation, okay. C goes to C prime then goes to C double prime, following the translation and then the reflection. If you look at in terms of coordinates, if you had the coordinates for C prime and then you talk about a reflection in the x-axis, right, you're just switching the sign of the y-coordinate, so it would be, to A comma negative B, right, so you could see where that would work. If you want to write down coordinates, maybe you write down coordinates on the side and then just graph what the coordinates are. So there's different ways you could go about this, right. For instance, if we just wanted to write down the coordinates, if we had C was at 1, 2, and then we follow the translation, C prime would be negative 3, 4, right? We would subtract 4 and add 2. So we subtract 4, then add 2. Okay? And then if we want to go to C double prime, okay, we would take the reflection across the x-axis, and the x value doesn't change, and the y value changes signs. And so we could see that point. C double prime would be at negative 3, negative 4, just like we'd expect if we followed the coordinate rules. So some different ways you can go about that. This is our end goal here, to graph that image after the composition of the two transformations. Let's see another example here of a translation followed by reflection. So we have a triangle, and I'm just going to write down coordinates here. Okay, so we've got A prime, B prime, C prime. So first we're going to take A, B, and C, and we're going to follow the translation. So we're going to go plus 3, minus 5. Okay, so all the coordinates here are going to be x values plus 3, y values minus 5. Okay. x value plus 3, so 1 plus 3 is 4, minus 5, that's 0. And then c prime, 5 plus 3 is 8, and then 3 minus 5, negative 2. So you don't necessarily have to graph this. I think it can be useful if you wanted to graph this and then graph each image, because you can make sure that it looks about the same. Does it look like the triangle is staying congruent? Because it should be. That way you might see if you make a mistake somewhere. Okay, but I'm just showing you different ways to do these. Now a double prime. Okay, so now we're going to be the reflection. So the double prime here, the reflection across the y-axis. So when we reflect across the y-axis, the x values will change signs. So we're going to have negative 4, comma 0, and c double prime would be at negative 8, negative 2. Okay, and so now I'm going to graph that point. A double prime, B double prime, and C double prime. So negative 6, negative 4. Right, so we're going to go over 1, 2, 3, 4, 5, 6, then down 4, 1, 2, 3, 4. And we're going to have A double prime right there. Okay, so A double prime right there. Okay, and we have B double prime at negative 4, 0. 4, 0, and C double prime at negative 8, negative 2. And that would be A double prime, B double prime, C double prime. And we'd have a triangle there. That's our final resulting answer after we do the translation. So we took these points and translated them using the coordinate rules, and then we reflected these across the y-axis. So there would have been some triangle over here, we reflected across the y-axis, and we get our final image, the double primes, using the proper notation, so we make sure we recognize that's what happens after both of those transformations in the one problem. All right. Well, trading places trivia. The only broadcaster in baseball history to be traded for a player. He's got some local Detroit connections. This man, Ernie Harwell. Ernie Harwell, famous broadcaster of baseball for many years, especially around the Detroit area. But he started out doing some minor leagues. He was working in Double-A in Atlanta, and he was heard by the owner of the Brooklyn Dodgers, who traded him because their broadcaster, a legendary himself, Red Barber, was having some medical issues. So they traded a catcher, Cliff Dapper, to the Atlanta Crackers for Ernie Harwell. The only time that's happened in baseball history. Harwell worked for the Brooklyn Dodgers and a few other teams, for a few years before he took over for the Detroit Tigers in 1960, and he retired from broadcasting Tigers games in 2002. So he's a well-known legend around Major League Baseball and especially in Detroit. All right, he had a couple of famous calls when people struck out or after double plays. You can look him up. I'm not going to try and recreate, but he was well known for his way to tell a tale and call a game. Let's look at some other transformations. We can combine any. We did glide reflections. There's not names for these, and we do like a translation or rotation we're going to see here. So there's not a name we could give those, but we can compose any transformations, and we're going to see here what happens when we change the order of the transformations. So first we're going to do the translation followed by the rotation, then we'll do the rotation followed by the translation. Okay, so first up, we're going to do the translation followed by the rotation. Okay, and I'm just going to write out the coordinates here. Okay, this would be for part A. Okay, first the translation. So A prime, we're going to say minus 6 plus 1. So we're going to subtract 6 and then add 1. B prime, we're going to subtract 6 and add 1. And then C prime, okay, we're going to subtract 6 and add 1. And now we're going to do a 90-degree rotation. So 90-degree rotation is going to take A double prime. Okay, we take our coordinates, the x and y coordinates, we switch them, we switch the sign of the new x coordinate. So it's going to be negative 2, negative 3. Okay, B double prime. Okay, it's going to be at negative 6, negative 5. And C double prime is going to be at negative 4, negative 1. Okay, so I'm going to graph now this double prime here. I'm going to do it on my first graph so I can do the other order here on the second one. So I'm going to have negative 2, negative 3. So I go negative 2, negative 3, and I get smaller graphs here because I try to do both of them next to each other so we can see there could be a difference. Then we have negative 6, negative 5. Right there. Okay, so we should mark this A double prime, B double prime. Okay, and then C double prime, negative 4, negative 1. Okay, so we'd have a triangle there. That would be for this first part. That's this first one here, when we would do the image after the composition in the order they're listed. And now for B, okay, so right, this is A. Now for B, we're going to reverse the order. So we're going to do the rotation first, then the translation, okay? So first the rotation. So for B, that we'll do right here, first the rotation. So A prime, okay, we're going to take this point, right, and we switch the x and y, and then switch the sign of the new x coordinate. So it's going to be -1, 3. Okay, so we have -1, 3. B prime will be at -5, 1, and C prime will be at -3, 5. And then I'll mark them down the side here. So A double prime. Now we're going to do the translation. So now we're going to subtract 6 and add 1, right, to our x and our y. B, keep on the right, D. B double prime. All right, we're going to subtract 6. That'd be a -11. And then add 1 is going to be at 2. And C double prime, we're going to subtract 6 would be at -9. Add 1 would be at 6. So even without graphing, we can see this final image is not going to be the same as the one here. The order matters. When you do a composition, if you're supposed to do a translation, then a rotation, you need to do the translation first, then the rotation. If you switch the order, you are not going to get the same image double prime at the end. So make sure you're paying attention to the order, right? Does reversing the order matter? It sure does. This triangle is not going to be the same as the one we had here. -7, 4, -7, 4 up here, -11, 2, something over here, and -9, 6, something here. We're going to have a triangle in this region of the graph, right, that is not going to be the same as what we had here. So make sure you're paying attention to the order. It does matter. All right, let's do one other here. So we're going to take the segment FG, and we're going to do the composition, and we can reverse the order again. So in this case, we're going to do a rotation 90 degrees. So for part A, we just have 2 points. So F prime, okay, 90-degree rotation, that's going to be 5, 4, and G prime is going to be at 2, 1, right? Switch them and switch the sign of the new x coordinate. And then we're going to take F double prime, and now a reflection across the y-axis, right? So it'd be -5, 4, and G double prime would be at -2, 1. And then if we take B, that means we're going to reverse the order. So first we're going to reflect across the y-axis. So in this case, we reflect across the y-axis. We're going to switch the sign, all right, of the x-coordinate. The y doesn't change, -4, 5. This would be for F prime. G prime, okay, is going to be at -1, -2. And then if we do F double prime, now we're going to go 90 degrees around the origin. So again, we're switching the order. So first we did the reflection, now we're doing the rotation. So the rotation is switch them and switch the sign of the new x coordinate. 5, -4. And G double prime is going to be 2, -1. And you can see close, but still not the same as what we'd get from the original order. So rotation followed by reflection. We do the reflection followed by the rotation. We don't necessarily get the same image. You might. There are certain instances where it does come out the same, but often it will not. So you really want to be careful. Follow the order given as what you're told. If you're supposed to do rotation followed by reflection, do it in that order. If it's a reflection followed by rotation, you do it in that order. As we can see, those things can make a difference. You can graph, right, and then see, how do I work with the graph, or just paying attention to your coordinate rules. And our goal is here to graph the double primes. If I graph those, again, we would see they're not necessarily the same. So make sure when you do a composition, you understand each individual transformation and how you can work with those. Follow them in the order they're given. Use the proper notation for prime and then double prime for each image you get as you go through the different compositions.